Following on from some of the earlier videos, I just want to elaborate more on this theorem. So this theorem requires f of n. It requires f of n to be continuous, positive, and decreasing. So if you have an f of n that's weird like this, you can cut it up right here. Let's say here, and then set your capital N to be here. So now for all x greater than capital N, or all x greater or equal to capital N, then you can see that it is continuous. So from here, it is continuous, positive, and decreasing. So if you have a weird function like this, function like this, it requires it to be continuous, positive, and decreasing. So you can cut it up right here, and then set your capital N to be right here. So now for all x greater or equal to capital N, then everything will be true. So even though we are trying to determine whether or not this will converge or diverge from one all the way to infinity, there's a theorem we've seen in the past that even though you're trying to determine from one to infinity, you can just look at it from some arbitrary nth term all the way to infinity, from some arbitrary nth term and all the way to infinity. If this thing converge, then this will also converge. If this diverge, then this will also diverge. So there's a theorem in the past that states this. So you do have the right to, even though you're investigating from 1 to infinity, even though you're investigating from 1 all the way to infinity, there's a theorem in the past we've seen that you can actually cut out right anywhere, and then if this thing here converges, then this will also converge. We've seen that in the past, and we've seen this example in the past. So if you're trying to determine whether or not this will converge, or if this will diverge, you do have the right to cut it up right here, and then determine the tail end of the series, whether or not this will converge. If this thing here converge, then well, this is a definite number. This is a definite number. So if this thing converge, then you're adding a definite number, then the whole thing will converge. If you cut out right here, if this thing here diverge, then here you're adding a definite number. If this thing here diverge, then the whole thing here also diverge, because this is a definite number, and definite number. So you do have the right, even though you're trying to investigate from 1 all the way to infinity, you do have the right to just set capital N. You do have the right to set capital N anywhere. You can set it up here, but just don't set it up here. Don't set your capital N here, because this is increasing. It requires it to be continuous, positive, and decreasing. So maybe you can set up here, capital N here, or capital N over here, as long as it's always decreasing. Okay.